Hey guys, just a quick update on the power supply. As I was saying the other day, I need to create a negative voltage buffer, voltage follower to be technical, for the panel meter because the way I was running its negative lead off of the emitter of the comparator transistor was introducing noise into the circuit. First thing I want to point out, I have got a mock-up of that working. Not perfectly, but I'm very happy because I don't have the noise, and so it's a little bit, it's not going to focus. I've got a whole load of other stuff on in here that's contributing to the noise, but if I turn everything off, it drops down to 50 to 60 microvolts, which is where it was without this connected in the first place. So that's good, negative voltage buffer's worked out and meter's running. It's currently just an LM358. Don't worry guys, I know that thing can only source about 10 to 20 milliamps. 10's well within its safe limits. The panel meter takes exactly 10 milliamps, so don't worry. Anyways, here is the problem. The actual voltage is 5.189, and as you've seen in the previous video, the panel meter is bang on accurate. Going through the LM358, which has an error voltage offset of like 2 to 7 millivolts, we've got 5.185. It's only a couple of millivolts, but I still need to trim that out. The other problem, I'm just going to have to turn the load on. Could do it with resistors, but I'll do it this way quickly. Oh, damn. So it's really hard to do it like this. I can't wait till I get the camera set up. Sure you can't all wait either. I'm just setting 5 amps. Oh, God. Keep pressing the wrong button. Trying to set 5 amps, right, 5 amps. When I turn that on, if we look at the voltage on the meter, we see it doesn't drop at all. And yes, it's on. Now, if we look at the voltage on the panel meter, as I turn it on and off, we see it's moving. So there's a couple of problems here. One, the initial accuracy of the meter with this op amp is not correct. 2, the gain of the op amp is not quite right. That's what this trimmer's for here. 3, there appears to be something with the sensing that could be wrong too. So I'm not quite sure it's just the offset voltages on the op amp, excuse me, on the op amp and its gain, but I've got a funny feeling that one of the voltage rails, well, the positive voltage rail, is also dropping as the transformer gets loaded, and that's throwing it out too. It shouldn't. It should only matter what's between the black and yellow wire, but I'm going to have to do some digging into it. The good news is, it is working. The initial accuracy is only a few millivolts out, and the fully loaded accuracy is like 20 millivolts out or something. So, like, considering I've literally just mocked up this circuit, there isn't even like right component values and everything. It's literally just an op amp slapped to a piece of board for testing, and it's proved the theory is going to work. So, I'll play around with trimming the offset and the gain and all that sort of stuff. Looking at sensing losses, whatever. See if I can get this right. If I can't, I might use a better op amp. I'm trying to do it with an op amp that I can do it on a single rail with. There is an OPO7 CP sitting here, but the thing with that is it doesn't want to go down. They don't like to go all the way down to the negative rail. They're not rail to rail op amps, so it's going to take more fancy circuitry to get that to work. It is high precision, it would work better, but it will take more circuitry, and I don't want to do that. I do have another option. these meters do come, as mentioned in another video, in a 4-wire version, which, as I pointed out in that video, I don't think the accuracy is as good, and I'm possibly using fake parts. So I don't know, I might have to order some, give them a go, but I'm going to play around with this first because this is an actual legitimate meter made by Riden with an ST Micro controller running it. Yeah, so that's the update on that. Negative voltage buffer is coming along. Now, I'm going to make another video pretty soon. I wanted to go over a couple of things that are going to be coming up. You know what, I'll just put it in this video instead of making another video. My function generator has a problem with the USB controller chip, but the function generator itself works perfectly fine. But the USB controller chip that allows it to communicate with the computer is not functioning, and I need to buy one of those and replace it. That allows me to upload custom waveforms that I can draw myself in the software on my computer, upload it and output it off of that. So I want to fix that. There's a repair for this coming up. I'll go over what software I'm currently running and using. My component collection, we're going to go over this too, because this is actually more than what meets the eye here. You'd be quite surprised what's tucked away. And then I've got some random things. This is another subject. These guys, their prices have skyrocketed lately, and their parts collection's shit anyway. I'm always having to order stuff online. I just wish you go back to the old days where there was more components in stores, better quality. But yeah, anyway, I literally just keep this book here because I know where the freaking, I can find the resistor table, and if I get confused on capacitance values, I've got just a few handy things lying around here. And then when you do want jelly bean parts and you can't be bothered to order them, you can just have a quick look in here and see what they've got. Run in and grab it. But even half of this stuff's getting discontinued, so anyway, that's that. I'm going to do a little review on this little differential RF amplifier. Supposedly used as an analog devices part, but I don't believe it. It's like a copy. There is a video coming on this one too. This is for a scope. This is, I can't remember the specs on it. I'll have to look it up. But I think it's only like 10 megahertz or something. I really can't remember, but that's got a problem with it. I've got to make a different power supply for it and put it in a different box. That's what that box is for. So there's a video on that. I've got to build a box to shield this. Maybe improve the circuitry a bit. Definitely solder the other side of the SMAs to the bottom ground plane. Dumbasses. Anyway, yeah, there's a few videos on that. Grabbed some parts off of Amazon. I never do this because all the transistor kits on eBay and that are fake. But I was having a look at reviews, and apparently the stuff on Amazon's not fake, from some sellers, yeah. But anyways, I ordered these two kits, and I gotta say I'm actually shocked because I've tested a couple of the ICs, just a couple of op amps just to see the input offset voltages and stuff like that, if they match what the data sheet says, and they do. So judging by that and the actual look, I actually think these are all real. I have not yet tested the transistors, however. These entire boxes are only like 15 or 20 something bucks, so you know, if they are all just rubbish or fake, it doesn't bother me. It's not a whole load of money down the drain, but you know, if they're real, great. So once I'm finished analysing that, do a video about that too. Yeah, that's all for now, guys. I mainly just wanted to post an update on the negative voltage buffer and what's happening with that. So I'll post a video later on and let you guys know what direction I'm going with it. Whether it's going to be playing around with the existing circuitry, trying to trim this op amp, or using a better op amp in different circuitry. Or a different op amp in the same circuitry. You just never know. Anyway, we'll see you guys. Bye for now.